Dear student, today we consider some requirements for performance of final project, the name of the project, 3D model, anti-static structural stress analysis. This project is conducted in frame of the course, the name of course, methods of analysis, and synthesis of design solves. This course is intended for students of specialty, computer science and software. The lecturer is me, Danenova Gulmira Talendiyevna. I'm Associate Professor of the Department of Information Technologies and Security at Karakanda Technical University. Let's begin. Before we consider the requirements of the project, we begin with the aim of the project. The aim of the project is to learn finite element analysis for solving engineering problems. Besides that, we need to work in the ANSYS environment with 3D object to determine stresses and strains. Every student will get the task, such as an example. The example you can see on your screen. We need to determine the maximum stress in the x direction for point A and display the deformation feature. The other tasks are the next. How should this be modeled? We need to compare results with the results obtained from normal calculations. Topics are the same, the next. Element type, real constants, modeling, plot results, output graphics. On your screen, you can see the example of 3D model. Every student will get the 3D object, and every student needs to determine strains and strain. Before we do the final project, I'd like to show some techniques of 3D modeling. Now we will learn some techniques on modeling of 3D object. On your screen, you can see link to this video. At the end of lecture, this link will be in reference, and you may see this video on your free time. Okay, let's begin to study some techniques of modeling.
Okay, In ANSYS, again, since I'm not doing a simulation, I'm going to skip all the steps and just jump to modeling. And I'm going to use these menus in here. So the first thing I'm going to say is let's switch to a 3D view and create 3 key points in the active CS. At points 0, 0, and 0, apply in here, and then z of -1, apply, and then make z 0, and y of 1, okay. So I have 3 key points in here, 1, 2, 3, which I'm going to use to generate or to make a new active coordinate system. So I come to work plane, local coordinate system, create local coordinate system by 3 key points. So first I pick the origin, and then this is going to be my new x, and this is going to be my new y. Call it 11, that's okay, and then I click OK. So if you see, I have a new coordinate system in this location. The other thing that I have to do is to come to work plane, align the work plane with active coordinate system. I haven't yet made, so I have to change active coordinate system first to specified coordinate system, click OK, give the number 11, okay. So the coordinate system that I made with these 3 key points is now the active coordinate system. Come to work plane again, align work plane with active coordinate system. So right now my work plane and my coordinate system are attached to one another. So now that I'm done with this coordinate system, I'm going to delete all the 3 key points. They're gone. Now I'm going to create an area, a circle by, no, but not by 2. Okay, I'm going to give a circle. There are 2 ways now for me to create a solid circle. One of them is by dimensions. So I click here, and if I say outer radius of, let's say 1. Oops, or I just picked 1. So this radius is 1. And if you see, right now it's in YZ direction of the previous coordinate system, or the global Cartesian coordinate system. But since I made a new coordinate system in which my X is in this direction and my Y is in this direction, the circle is made in a coordinate system in which its X axis is in the -Z direction. I'm going to delete this area and create another circle using solid circle, given X of 0 and Y of 0 and a radius of 1.5, click OK. I have the same area, the same circle in the same direction. Now I want to come and do operate, extrude the areas and along normal, which means in the x-axis of the global coordinate system, which is going to be the z-axis of the new coordinate system or local coordinate system. I'm just going to click along normal, pick this area, click OK, and give, let's say, a length of 4.5 and OK. So this area is made for me. Now I'm going to use another command in modeling, which is copy. And I'm going to copy this volume in the negative 4.5 of the z direction. So if I do this, so remember the length of this cylinder was 4.5. So if I click OK, I have 2 volumes. This is the first volume and this is the second volume that are made for me. If I come here, list, volumes. I have volume number 2 and volume number 1 and volume number 2. Now let's switch our change our active coordinate system to global Cartesian, and also come to here and align work plane with active coordinate system. Now we're back to the previous or the global Cartesian coordinate system. I'm going to come to create another circle. Let's say by dimensions, or let's do this one at point 0 and 0 and radius of 1.5. Click OK. This new area or circle is made for me in the direction of the active or global coordinate system. I'm going to go ahead and do the extrude again for this area along normal. So I'm going to pick this. Okay. And then the same way, so this is made for me. Copy this, or should be volume. Copy this volume in the negative 4.5 in the z direction. So I have these 4 volumes in here. Then the next thing I want to do is to define another another local coordinate system. So I come to here, or let's make 3 key points again in the active coordinate system. And the y of, let's say, minus 7. Apply. So first one is made in here. Now in x direction, I want to make, or in z direction, 1, apply, 0 this, and 1 in here. Okay, so I'm going to use these 3 key points to define another active coordinate system. So by 3 key points, x direction, and this is my y direction. Call it 11, and then change active coordinate system to number 11. Okay, and let's also say align work plane with active coordinate system. Now create, and let me delete these key points in order to prevent confusion. So I'm going to come to delete key points, this, this, and this. Okay. Now back to create a circle. The radius, I'm going to give the radius of, let's say, 2 to this one. And then again, I'm going to extrude this area along normal. The length of extrusion, I'm going to say it's, let's give, for example, 9.5 for this one. Okay, so I have made this area in here. Now I'm going to switch back to global coordinate system. Also align my work plane with that. And look at this model from front and create another circle. Most of the areas I'm making today are just circles. So solid circle at the x of 6 and y of 0 and the radius of 2.5, let's say. Click OK. So I have this area made in here. If I click like this. Now I want to make 2 more key points in active CS at y's of minus, let's say, minus 10. Apply. And plus, let's say, 12. Apply. I'm going to use these key points as the two ends of my axis to do a revolve in here. So then I'm going to come to operate extrude areas, and this time instead of going along normal, I'm going to say about axis, which is revolve in here. So I'm going to say about axis, pick this area, apply. I have to pick two ends for the axis. I'm going to pick this one and this one. Okay. And degree of rotation, I'm going to leave for 360. Number of volume segments. This value will divide the volume into as many numbers as you want, as you provide in here. I'm going to say let's make it 4 and click OK. So I have, if I look from front, I have this volume in here.
Now we have watched some techniques on 3D modeling. On your screen, you see 20 variants of tasks. Each student will have his own task, one of these 20 tasks. You may see some variants of 3 models. Using these techniques that we watched some minutes ago, you need to create 3D model. You can use commands such as extrude, copy, add, and others. At the end of your work, you should get some results such as strains and stresses in each direction, X, Y, or Z. On your screen, you may watch strain of 3D model, displacement, exactly, displacement in all directions, X, Y, and Z. Displacement you sum. All pictures you should add to your final project. Before we finish our lesson, you should answer on 3 control questions. What finite elements do you know? Finite element discretization. And third question is approximation. I would like to share some reference according our final project. This link on the video that we have watched on this lesson. This video about some techniques on 3D modeling. You may use these techniques in your work. Thank you for your attention. And now let's begin our final project.